GATE 2019 Metallurgical Engineering Question 47. The critical radius in nanometer of nickel nucleus during solidification at 1673 Kelvin is, it is given that the enthalpy of fusion of nickel is 2.65 into 10⁹ joule per meter cube. Liquid solid interfacial energy is 0.5 joule per meter square. Equilibrium melting temperature of nickel, it is given to be 1728 Kelvin. Now the critical radius that we need to find can be determined using Gibbs free energy, and the change in the free energy per unit volume to form a solid embryo of a spherical shape of radius r from liquid of pure material involves the variation of volume free energy and the surface free energy associated with the solid liquid interface, and mathematically it is given by delta Gs. It has two components, delta Gv and delta Gs, where delta Gv is the change in free energy on solidification associated with the volume, and delta Gs, it is the free energy associated with the interface. So if you look at the G versus R curve, free energy change, so here Gs represents the change in free energy associated with the interface. It shows the amount of energy needed. The delta Gs tells us the amount of energy that is needed to create an interface, and mathematically it is the surface area of a sphere 4 pi r square into the surface energy. While on the other hand, delta Gv, it describes how probable it is to have a phase change, and mathematically it is equal to the volume of a sphere 4 by 3 pi r cube into delta G, that is volumetric free energy. So total Gibbs energy is the addition of the volumetric free energy and surface free energy. Now the critical radius r star, it occurs when delta G has a maximum, and it is given by the condition, that is, what is the principle of maxima and minima? You will follow that method. The derivative of total Gibbs free energy change should be equal to 0. That will tell you the maxima. Okay, and upon derivating the equation with respect to r, we get the value of r star as 2 sigma by delta G. Now upon further solving this equation, we can further write delta Gv can be written as delta Hv minus T delta. Also it can be written as delta Hv minus T. What is delta S? Delta S is nothing but delta Hv upon melting temperature. Okay, so this can be written as delta H 1 minus T upon Tm, where delta H is latent heat of fusion, Tm is melting temperature, gamma is solid liquid interfacial energy. So we will use this expression to compute the value of critical radius. Okay, so we will put all the unknown values So the equation can be written as R star is nothing but, here delta T is degree of undercooling and it is nothing but Tm minus T. So R star can be found to be, what is the value of interfacial energy? It is given to be 0.5 joule per meter square. Melting temperature is given to be 1728 Kelvin. Delta HF, that is the latent heat of fusion, it is given to be 2.65 into 10 raised to power 9. Degree of undercooling, it is 1728 minus 1673. Upon solving this equation, we will get the value of 11.85 nanometer. The critical radius of nickel nucleus during solidification at 1673 Kelvin is 11.85 nanometer. If you want to know more about the concept of critical radius, kindly refer lecture 90, Introduction to Material Science and Engineering by Professor Rajesh Prasad, Department of Applied Mechanics, IIT Delhi. Thank you.